Assalamualaikum and hi everyone. Nernst equation part 3. For the third part of Nernst equation, you are going to use the Nernst equation to determine equilibrium constant K when E cell is equal to 0. Predict the spontaneity of a cell reaction. Okay, we move to the next slide. So at equilibrium, there is no net reaction occur where Q equals to K and E cell is equals to 0. So, when we refer back to the Nernst equation and we substitute E cell equal to 0 and we change from Q, change into K, so we'll get this formula. Okay, for example 4, calculate the equilibrium constant K for the following reaction. So this is the overall equation and given to you the standard reduction potential. So you have to find out the anode and the cathode from the overall equation. So we can clearly see that copper, and for this copper 2+, there is increasing oxidation number. So copper undergoes oxidation. Copper will become the anode. Ag plus now become Ag. So from positive 1 now become 0. Ag plus undergoes reduction. So Ag is equal to the cathode. Okay, so you write down the half equation at anode and cathode. Okay, so we notice that the number of electron here is imbalanced. So you have to time the whole equation for the reduction by 2. And then finally you can cancel out the number of electron. So this is the overall equation. Why that you have to write down the half equation at anode and cathode? So it is easier to you to notice the number of electron. N equals to 2. And then from here we will know which one is the anode and which one is the cathode. So next we have to calculate the anode cell. Okay, so we will find out the anode cell equals to positive 0.46 volt. So positive sign is insisted. Okay, it's compulsory. Now write the equation here. Okay, because we want to find out the equilibrium constant. So therefore the E cell is equal to 0. Substitute all the values and we find out the value of K is equal to 3.47 times 10 power of 15. And there is no unit for K. Right, so for the spontaneity of a cell reaction, so the reaction is at equilibrium when E cell is equal to 0, spontaneous when E cell is positive, and it can be non-spontaneous when E cell is negative. Right, so example 5. Will the following reaction occur spontaneously at 25 degrees Celsius if the concentration of Fe2 plus ion is 0.6 molar and concentration of Cd2 plus ion is 0.01 molar? Given to you the overall equation here. So find out the anode and the cathode from the overall equation. Okay, so we notice that Fe2 plus become Fe, positive 2 becomes 0. So Fe2 plus undergoes reduction. Okay, reduction. Whereas for Cd becomes Cd2 plus, there is increasing in oxidation number from 0 to positive 2. So Cd undergoes oxidation. So Cd is the anode and Fe is the cathode. Okay, so from here we will get this overall equation. Okay, and then you have to calculate the anode cell that is negative 0.04 volts. Okay, right. So next, from this half equation, so we know that the number of electron transfer is N equals to 2. And for the Q, you have to remember concentration of the product divided by concentration of the reactant. So therefore, concentration Cd2 plus divided by concentration Fe2 plus. So solid is not considered in Q expression. Right, next, write the Nernst equation. Okay. Right. So remember, you have to define what is Q. Okay. Substitute the expression for Q. Substitute all the values here. And you will get that E cell is 0.013 volts. So because the E cell is greater than 0, so therefore the reaction is spontaneous. Alright, so here is the example of a tight cell, retouchable and non-retouchable. For retouchable, the example is lead acid battery and nickel cadmium battery, whereas for non-retouchable, example dry cell, alkaline cell and mercury cell. Alright, so that's all for today. Hopefully we can see again in the next class. Bye and assalamualaikum.